Circuit breakers are designed to perform two main functions. They are designed to interrupt circuits under normal load conditions and under fault conditions. If we simplify its operation to its most basic step, a circuit breaker interrupts a circuit by moving contacts apart. But in reality, it's a little more involved than that. A controlled arcing demonstration using a disconnect will help to show why. In this demonstration, a closed disconnect establishes or makes an energized circuit. When the disconnect switch is opened, current tries to bridge the gap in an attempt to maintain the circuit. The air heats up and becomes a conductor. As a result, an arc forms. The heat from an uncontrolled arc in a circuit breaker can cause a rapid and violent expansion of the nearby air and gases generated by the arc. The result could severely damage the circuit breaker and surrounding equipment and structures, and injure personnel in the area. A circuit breaker plays a critical role in a T&D system. It not only has to separate energized conductors, but it also has to quickly extinguish the arc that is created before any significant damage occurs. In a circuit breaker, a number of factors work together to extinguish an arc and interrupt a circuit. The main factors we're going to look at are speed, distance, cooling, dielectric strength, and current zero. We can use this simplified illustration to demonstrate the factors that help to extinguish an arc. The illustration includes two conductors connected by contacts to make a circuit. To break the circuit, the speed at which the contacts separate is important, because the faster the contacts open, the less time there is for an arc to form and maintain itself. When the contacts separate rapidly, there is little time for the space between the contacts to heat up and become a conductor. Distance between the contacts is also important. As the distance increases, the arc has to stretch in order to maintain current flow. The greater the distance, the more voltage is needed to sustain current flow, and eventually the arc will extinguish. Cooling refers to any physical effects that take heat away from the arc. In general, when air and gases are heated, they become electric conductors. The hotter they get, the better they conduct. So breakers are designed to take heat away from the arc. Some common ways that an arc is cooled in a breaker include directing a blast of air or gas at the arc, forcing the arc against cold metal or insulating materials which rapidly absorb and dissipate heat, and submerging the breaker contacts and the arc in insulating oil, which absorbs and dissipates the heat.